Okay, this video we're going to be doing synthetic division. Synthetic division is just another way to divide polynomials. And in order to do it by synthetic division, you have to have a binomial. Okay, so what we are going to do is we're going to take this long polynomial here, and I'm going to divide it by that binomial. So synthetic division is basically just another way to divide, and it's just a shorter, faster way. So there's a couple different things you need to keep in mind. One is I'm going to write down the coefficients of all of the variable terms. Okay, I'm going to write them below. So I get 6, negative 11, 3, negative 1, and negative 15. Okay, all I'm going to do is write the coefficients. I don't care about the variables because they go in order 4, 3, 2, 1, and then 0. Then I'm going to take the n minus 2, and remember how we always solve for zeros and all that stuff is we take the opposite of this number. So the opposite of that would be 2. I'm going to put that up front. And then I have this box going through that kind of just separates some values. It separates the 0 from all the coefficients of the polynomial term. So now this is a process. We need to follow the process every single time. So I am going to just bring down the first term always. Whatever that term is, always bring it down. Then you are going to multiply by 2. So 2 times 6 is 12. Okay, so we drop, we multiply, all right, and then we add. So negative 11 plus 12 is 1. Then I do the same process over again. 2 times 1 is 2. Then I add. 3 plus 2 is 5. Then I do the same thing again. I multiply. 2 times 5 is 10. Then I add. Negative 1 plus 10 is 9. Then I multiply by 2. And then I get 18. Then I add and I get 3. Okay, so we did all our synthetic division. Now what I need to do is write the answer. Okay? So what happens when I do synthetic division, when I divide by a binomial, this term is no longer a 4. I'm dividing by it, so it actually makes it smaller by 1. Always the case. So n to the third plus, then I'm going down now, so this would be an n squared term. I'm going down again, so this would be plus 5n. I'm going down, so I don't have any n's next to the 9. But if you notice, there is a 3 at the end. That is our remainder. So it's plus 3 as a remainder. And how I write it is I take the 3 and I'm dividing by what I actually divided by, which was the n minus 2. Okay? So now let's rewrite my answer just a little nicer. And we should be good to go. So my answer is 6n to the third plus 1n squared, or just n squared, and then plus 5n plus 9 plus, now my remainder, 3 over n minus 2. So there is your answer to this problem on the board. Okay, the first problem that we're doing. Let's go to the second one. Okay, again, we have a binomial being divided into a long polynomial. So again, I want to take this and do the opposite. I want to find the 0. So the 0 would be negative 6. Then I'm going to take the coefficients of all of these terms. That's a 1. This is a 6. But if you notice, I have a 5, I have a 4, and then my next term is a 2, so it skips the 3. In synthetic division, you need to make sure you account for that. So the actual coefficient of that 3, or the x to the third term, is a 0. So whenever you're missing a variable degree, so I'm missing the 3 here, I'm going to put a 0 in its place. Then I continue. Negative 6 for here, negative 35, and then a positive 6. And now I continue as I did before. I'm going to drop. I'm going to multiply. That's negative 6. I'm going to add. That's 0. I'm going to multiply. That's 0. I'm going to add. That's 0. I'm going to multiply. That's 0. Add negative 6. Multiply. That's 36. Add. That's 1. Multiply negative 6. When I add, I get 0. So the cool thing is at the end, if you get a 0, if this term is a 0, that means that you have no remainder. So that means that x plus 6 can go into x to the 5th plus 6x to the 4 minus 6x squared minus 35x plus 6 evenly without having any remainder. So I'm going to now rewrite this with my variables using the numbers that I got down below. Okay, so I get 1x to the 4. Look how the 4 dropped a power from the 5. Okay, I originally had a 5, but then I divided, so it's 1 less. Plus 0x to the 3rd plus 0x squared minus 6x plus 1. I don't need to write 0 there because anything adding to a 0 is just whatever I had originally. Now I cannot leave my answer as that because I have zeros in there. I can make it look nicer because right now it doesn't look very good. So my final answer is x to the 4. My 0x to the 3rd is gone. My 0x squared is gone. So I have minus 6x plus 1. That is your final answer for this problem. Let's go to one more. This next one is going to now incorporate a whole bunch of stuff into it. Just some very differing answers that we're going to get for this one. So again, I have a long polynomial. I am dividing it by a binomial. Since I'm dividing it by a binomial, I can use the synthetic division. What is the 0 here? That's negative 4. So negative 4 is on the outside, and then I'm going to take the coefficients of all of my terms. Okay, so I get 8, 38, 24, but then again, this is a 2 and this is a 1. So I need a 0 in there to represent the squared term that I don't actually have. The 1 and then the 14 at the end. Remember we said the first one we're going to do is drop. Drop it like it's hot. Then I multiply. That's negative 32. Then I add, that's 6. Multiply, negative 24. I add, I get 0. Multiply, I get 0. Add, I get 0. Multiply, I get 0. Add, I get 1. Multiply, I get negative 4. And when I add, I get 10. So this number is our remainder. So now I can rewrite this bottom piece here as 8m to the 4. Remember I had to drop the power down 1. Plus 6m to the 3rd plus 0m squared plus 0m plus 1 plus, now we're my remainder, which is 10 over the m plus 4. Okay, but again I have zeros in there so I can cancel them out, and I rewrite my answer as 8m to the 4 plus 6m to the 3. My m squareds and m terms are gone, plus 1 plus my remainder, which is 10 over m plus 4. And that is your answer.